Okay, today we're going to look at properties of real numbers. Real numbers are made up of all rational numbers and irrational numbers. So we're going to be talking about what those kinds of numbers look like. And this should, again, be reviewed. So some of the vocabulary, you might need a refresher. There are 5 subsets of real numbers. And the first subset we think of are called natural numbers, also sometimes referred to as counting numbers. And these were the first numbers that you would have ever heard about when you were in preschool or kindergarten. They're the numbers that you started counting with, thus the name natural numbers or counting numbers. Then the next set of numbers are called whole numbers, and those are made up of all of the natural numbers and the number 0. And so you can see I've listed out those sets of numbers. The next subset of real numbers are called integers. And integers are all of the whole numbers, so you can see we're kind of building on each subset. So we have all the whole numbers listed, but it also includes their opposites. So the opposite of 1 is -1. The opposite of 2 is -2. So it has all of their opposites. Those are integers. The next set of numbers is called the rational numbers. Rational numbers are all of your fractions and decimal values. They can be written as a fraction in the form a over b, where both a and b are integers and b is not 0. So like 7/8, 1/4, -2/3. Anything that can be written in that form is a rational number. Rational numbers can also be written as either terminating or repeating decimal fractions. So if you had a repeating decimal where you have a fraction, say you have 0.3 repeating and it goes on forever, that's a rational number. Or you could have a terminating decimal where you have something like 0.25. That's a rational number. So that's how you can identify rational numbers. The last set of numbers, subset of real numbers, is called irrational numbers. The square root of 2, the square root of 3, the square root of 3/8, pi. All of these are irrational numbers. They cannot be written in the form of a fraction where you have the numerator and denominator both integers. So the square root of any prime number is irrational. Square root of 2, square root of 3, square root of 5. Pi. Remember, pi is the ratio between the circumference and the diameter. It's irrational. Numbers which can only be written as a never-ending, non-repeating decimal fraction, which pi would fall into that category. Those are irrational numbers. Now your textbook gives you a little diagram to help you identify these. So we have notice here in the center are all the natural numbers. Then working out from there is the whole numbers. Notice that all of the natural numbers are also inside the whole numbers. For integers, we've included the opposites, but all of the whole numbers, all of the natural numbers are also inside the set of integers. So you can see how that builds out. Irrational numbers kind of stand alone from rational numbers. Both of these things make up the real number set. Now I have another little diagram and a little activity here for you to try and classify where the number belongs. So when you see this, N stands for natural, W is whole. Since I is irrational, we use a Z for integer. We use a Q for rational because it looks like a quotient of two numbers. So, and R is what we use for real numbers. So we're going to classify those. You might want to pause this video for a few minutes and try and classify where these numbers would belong. And once you feel like you know, I'll show you. All right, well, I'm going to pick a number to start. The number 7 I know is a counting number because I count with it. So that's going to go inside here. We're going to look for any other counting numbers. Actually, I see one. It's a little disguised, but the square root of 25 is 5. So it's going to go in here in the natural or counting numbers. Whole numbers, I know 0 is a whole number, so it's going to go here. And I am not seeing any other whole numbers. -5, however, is an integer. I know that 1.3 is rational, because it can be written as 1 and 3/10, or it can be written as 13/10. So it can be written in that fraction form a over b. You write it as 13 over 10. Since this is a repeating decimal, remember that repeating decimals are quotient or are rational numbers. 3/4 is a rational number. 5 is a prime. Remember, the square root of a prime number is always going to be irrational. 2 pi, if pi is irrational, then 2 times pi is also irrational. And that leaves 1 left, the square root of -2. And some of you may have had trouble where to place that. You may have looked at the -2 and thought, well, that looks like an integer. And maybe you looked at the square root and thought, well, maybe that makes it irrational. This was kind of a trick question, I guess, because this one doesn't fit in either place. This is called an imaginary number, and that falls outside of the real number set. We will be discussing those later on in the course. Now, your textbook does list all of the properties of real numbers. I have a link to a table, and I will put this link on my webpage as well. And if you take a look at this, you'll see the different properties you should be aware of. Commutative property of addition, commutative property of multiplication, which deals with changing the order. The associative property of addition and multiplication, which deals with changing the grouping. The distributive property, which the a gets distributed to both of the add-ins inside of the parenthesis. The additive identity property, which I will show you in just a little bit on another little page I want to show you. So that is one tool that you'll have to use. The other is a little nice, kind of a cute little way to remember the properties. Commutative, and I'll let you read those later. You might want to look that up on my webpage. But I want to talk about this one, the identity property. Think of the identity, the I in identity, and how I am the most important thing in the world, although I guess I don't really want you to think that, and I do not want to change. And that's the idea of the identity. So if you don't want to change, I don't want to change. For addition, adding 0, then you don't change. For multiplication, multiplying by 1, then you don't change. So that's one way to remember the additive identity and the multiplicative identity. And the inverse property, which sometimes students confuse these two properties. The inverse property is, what does it take to get back to the identity? So for addition, the 0 is the identity. So to get that, you would have to add the opposite to get that. For multiplication, to get a 1, to get the identity, you would have to multiply by what we call the reciprocal. So you'd have to switch that around, put 1 over x. And so those are just some ways to help you remember those properties. And so now we're going to do a few examples. All right, so for this first one, we're going to name the property illustrated. So let's think about what's changed. We might look at this parentheses and think maybe associative property. However, the only thing that's changed is -8 plus 8. Now we have a 0 in its place. So I'm adding the opposite. This is the additive inverse property. Okay. Name the property illustrated by, this is a second example here, 6 times 2 times 5 equals 6 times 2 times 5. But notice the grouping has changed. This is the associative property. And technically it's the associative property of multiplication. Now, we might look at that and say, well, what's the big deal? Why would I ever need to do that? Well, when you're multiplying, which is easier? Multiplying the 6 times 2 first and then multiplying by 5? Or multiplying the 2 times 5 first and then times the 6? Because here you get 10 times 6 is 60. Very easy to do in your head. So sometimes it's kind of nice to regroup numbers, whether you're adding or multiplying, to make the problem a little easier. Another example, name the property that's illustrated here. We'll notice that we're multiplying the 5 times the 8 minus the 5 times the 6. So we're using the distributive property. Identify the additive inverse and multiplicative inverse. So we have two problems we're being asked to do here for -7. Remember, we want to think, what do you have to do to get the identity? So the identity for addition is 0. What do you have to add to get 0? A +7. That's the additive inverse. The multiplicative inverse, remember the multiplicative identity is 1. What do you have to multiply by to get 1? Well, you'd have to multiply by -1/7, because the 7's will cancel. Negative times negative is a +1, so the multiplicative inverse is -1/7. Identify the additive inverse and multiplicative inverse for the square root of 1/9. Well, first of all, I'm going to think about what this means. The square root of 1/9 is the same as the square root of 1 over the square root of 9, which the square root of 1 is 1. The square root of 9 is 3. So I'm going to start by simplifying that. Now I'm going to find the additive inverse. So if I wanted to get a 0, I'm going to have to add a -1/3. That's the additive inverse. For the multiplicative inverse, remember we want to get a 1. If I want to get a 1, then I have to multiply by 3. So 3 is the multiplicative inverse. On this next problem, we are going to simplify this expression by using the distributive property. So the 4 is going to get distributed here. The 2 is going to get distributed here. So we have 4 times 3 is 12a minus 4 times b. Here we're going to have 2 times b plus 6 times a. Now we're going to combine like terms. So when we do that, we're going to group the a's together. So really we are changing the order. So technically we are using the commutative property when we do that, because we're changing the order. We're going to do 12a plus 6a, and we get 18a. -4b plus 2b is a -2b. So this is our answer when we simplify. Notice that this was a plus here. This next problem we're going to do is a little more complicated, and this is one where people tend to make a mistake, and it's because of this minus sign right here. So the first thing you're going to do is apply the distributive property here and here. But you've got to be careful because of this sign here. You're treating this like a -4 when you distribute. The minus sign gets distributed as well. So we have 6x minus 2y. That's going to make this a negative, or a minus 8x. And since we're treating this like a -4, so it's going to be minus 12y. Now we're ready to combine like terms. If you prefer, you can change this to adding the opposite. Remember, subtraction, we can change to adding the opposite. So if you prefer to do that, you can. Now we have a 6x plus a -8x, which gives me -2x, -2y plus -12y, so it's -14y.